This is video number 2 for our Reasoning with Algebra Introduction to Proof lessons. Again, definitely need to have the sound on, and it's very important that you listen to my explanations. And we are going to now use these and apply them to proving something. So let's flip the page. All right, so name the property being shown or use the property given in parentheses to complete the statement. So we're going to name the property or use the property. Okay, so what I want you to think about is what we're trying to figure out. If we're naming the property, we want to figure out what happened. Not what are we going to do next, but why can we do what just happened on the paper. Okay, so let's take a look. If x plus 4 equals 3x, then 4 equals 2x. So now what we need to think about is what happened so that we can actually say this. And what I see is I have x plus 4 on the left side, and then I end up with just 4. So somehow the x went away. I had 3x on the right side, and now I have 2x. So what I'm seeing is that probably we subtracted x from both sides, right? These canceled. We got 4 is equal to 2x. What is this that we just did? We subtracted, and when we subtract from both sides, the equation remains true. So the reason we could do this is the subtraction property of equality. That's the reason that justifies how we went from the first to from the if statement to the then. Let's try another one. If m equals 2n minus 5 and m plus n equals 16, then. Now, we have to finish the then statement. So this is different than this one. Here, the then was done. We had to say why. Here, we're told why because we're told we have to use this property. Okay, so substitution. So m is 2n minus 5. All right, so we're going to take this and put it here. So in place of this m, we're going to substitute this expression. So 2n minus 5 plus n equals 16. Okay? And how did we do that? Because this was this original m. In place of this m, we put the 2n minus 5. That's the substitution property. All right. Fancy geometric symbols here. If P is congruent to Q, Q is congruent to R, and R is congruent to S, then we have to use the transitive property. Now this is a new one, so let's go back real quick and make sure we remember what that is. Transitive property. Okay, here it is. Transitive property. If A is congruent to B, B is congruent to C, we can say that the first one is congruent to the last one. So let's take a look. P is congruent to R, P is congruent to Q, Q is congruent to R, R is congruent to S. So you see these right here and these right here. So we can then say that P is congruent to S. And I forgot my angle symbols. Angle P is congruent to angle S. Okay, make sure you get your symbols in there, symbols. And you see how easy it is to forget them. All right, now, this one does not tell us a property. This one has an actual completed if and then statement. So we have to figure out what property happened, okay? So if 2 times h plus 7 over 8 equals 3, then 2 times h plus 7 equals 24. Now, be very careful because the thing you want to do is look at this and you see this parentheses. You want to use the derivative property. But again, that's not what we're doing. We're trying to figure out what happened, not what are we going to do next. Okay, so how did we get from here to here? And what I see is I have an 8 in the denominator here. There's no 8 here. So somehow from here to here, I got rid of the 8. And the 3 turned into 24. I know 3 times 8 is 24. So what really happened here is we multiplied both sides of this times 8, right? And then the 8 went away here. We got 24 here. And what is that? That is the multiplication property because we multiplied both sides by the same thing. Property All right, so there's how we use those. So now we're going to actually do an entire equation from start, okay? So the original equation is 5x minus 12 equals 32 plus x. And then the steps here are shown, okay? Now what you'll find in a proof is often the actual in-between steps where you're actually doing the thing is left out. And then you have to figure out what happened, okay? Again, not checking to see if you can solve an equation, because we've already been doing that this year. I know you can. You're looking for the justification of each step. Again, what happened? Okay, so let's take a look. So we start with 5x minus 12 equals 32 plus x. The next step is 4x minus 12 equals 32. Notice I went from 5x here to 4x here, and I went from an x on this side to no x on this side. So what actually happened? We subtracted an x from both sides. Oh, that's my alarm. Okay. All right, so what did we do? We subtracted. So what is the justification to go from here to here? That's the subtraction property of equality. All right, so now here we are. We're at 4x minus 12 equals 32. Sorry, that got crooked. And we end up with 4x equals 44. So notice, we still have a 4x on the left, but the minus 12 is not here anymore, and the 32 is now a 44. So it looks like we got the 12 to sort of move over. So what happened was we added 12 to both sides. The 12 goes away here, and it adds on here. So what happened? That's the addition property of equality. All right, we're down to our last step. So we go from 4x equals 44 to x equals 11. How did that happen? What happened? All right, it looks like we divided both sides by 4. And so then that is the division property of equality. All right, so again, I'm going to read this to you one thing. We're not just asking, do you know how to solve an equation? Because if you're in geometry, you've passed 2 semesters of algebra, you definitely should be able to do that. We are looking for the justification, as in what happened, or why can we do that? Okay, so that's the key thing here. And again, I said I'm going to make 1 video per page, so it's going to be a little bit of a long lesson if you watch all the videos, but very, very important to get all the details, so I will see you on the next page.